So far we have two methods we've learned to solve systems of equations. One was graphing, it had its limitations. The second one was substitution. It also had some limitations because we wanted the variable that we're going to solve for to have a coefficient of 1. So now we're going to use another method called elimination using add and subtract. So here you're going to just do what it said. You're going to add or subtract to try to get rid of one of the variables. So the coefficients either need to be the same or they need to be the opposite. So if you see in this example, negative 5y and positive 5y, if we add those two together, those two variables will disappear. So we will have 3x plus 2x is 5x equals, over here the signs are different, so we're going to subtract and get 15. So divide by 5 and we get x equal 3. Again, our solution is an ordered pair, so we need to put this in either one of them. It doesn't really matter which one you put it in. So sometimes it's nice to avoid the negative number, so I'm going to put it in the second one, so it's going to become 2 times 3 plus 5y equal 31. So this is 6, so I would need to subtract 6 from each side. Get 5y equal 25. Divide by 5. Y equals 5. Remember, your final answer you do need to write as that ordered pair. The ordered pair 3, 5. So in this one we see the t's have the same coefficient, but they're both positive, so to get rid of those we would need to subtract the two. So 5r minus 9r is negative 4r, and 6 minus 22 would be negative 16. So make sure that you bring the subtraction across the equal sign. So the next step would be to divide by negative 4, and we get r equal 4. Again, put it back either one of them. I just think I'll put it in the first one. So we have 5 times 4 plus 2t equals 6. 5 times 4 is 20. So I would need to subtract 20 from each side and get 2t equals negative 14. Divide by 2 and get t equals negative 7. Again, remember the first letter of the alphabet is what represents your x in this case, so it would be the ordered pair 4, negative 7. So in this equation, what do you think we should do, add or subtract? Well, again, to get rid of these two, we would need to add the two. So negative 3 plus a positive 3 is 0. 4 plus negative 6 would be negative 2y equal 30. So divide by negative 2, and we get y equals negative 15. Again, you can put it in either one. I'm going to just put it in the second one, so I get 3x minus 6 times negative 15 equals 18. So that gives me 3x plus, and this would be 90 equals 18. So I need to subtract 90 from each side, and I get 3x equal negative 72. Divide by 3, and I get x equals negative 24. So again, write it as an ordered pair, negative 24, negative 15. This one I would need to subtract to get my x's to disappear. 4x minus 4x is 0. Be careful here. 2y minus negative 3y would become 5y. 28 minus 18 would be 10. Divide by 5, we get y equal 2. Oh, I'll put it back in the first one. 4x plus 2 times 2 equal 28. So this is 4, so I would need to subtract 4 from each side and get 4x equal 24. Divide by 4, x equal 6. So the ordered pair 6, 2 would be my solution. So twice one number added to another number is 18, and 4 times the first number minus the other number is 12. So find the numbers. So we do need to define our variable first here. So we can say x equals first number. And now we're ready for two variables, which is something different than what we've done, and y could equal the second number. So writing our equation, twice one number, 2x, added to another, plus y, is 18. 4 times the first number, 4x, minus the other number, minus y, equal 12. Now we can solve it by adding the two equations together and get 6x equals 30. Divide by 6, x equals 5. Again, you can put it in either one. I'll put it in the first one. So it's going to come 2 times 5 plus y equal 18. So that's 10. So I need to subtract 10 from each side. So that's coming off my screen. We get y equal 8. Technically, these do not really need to be written as an ordered pair. Just have your two answers, x equal 8, x equal 5 and y equal 8. And that is an equal sign on this. Looks like a